Turn the lights back on. Wow. Retro electro tech. When real audio ruled the world.
Hello again, all you lovely ladies and you handsome hound doggies. This is Retro Ernest of Retro Electro Tech. And what I have here on the bench is a Sansui 771. Sounds familiar, right? That's because this is the third one that I've taken into the shop in more recent times. This one was mailed to me about 3 or so months ago. I've had to set it aside and wait until I could free up a little bit and get it back on the bench to dive in further and start prepping things up for a recap. Initially, when this first arrived, I did an unboxing just to make sure that, you know, things weren't damaged during shipping. Then I performed a cursory power up, safely brought it up on the current limiter, make sure it wasn't going to let out any smoke or anything, and everything was okay there. Then I performed a basic function test. I wanted to see if this had any output, and I believe I recall there was some intermittent behavior on, I think, the left channel that may have been associated with the controls, perhaps dirty pots and switches. Although these are not too bad. There's a little bit of that, but not too bad. So as of right now anyways, I have a signal on both channels and everything is symmetrical. Everything is holding well. There doesn't seem to be any erratic behavior, any intermittency, any fluctuations or anything like that, any odd behavior. So whether or not I'm going to experience that same issue again, we'll see. If I do, then I'll tackle that at that time. So anyways, what I'm doing right now is prepping up for the recap that the customer wanted me to take care of on this. And of course I'm going to go through and perform an inspection as well as I go along and just give everything the green light, and you know, if I don't run into any other problems, of course. And otherwise, you know, while I'm doing that, I will, at the very least, because again these controls aren't too bad, I will perform a very thorough flushing of the switches and pots. Usually I flush them out with contact cleaner multiple times, let them drain out. You know, of course I work the controls repeatedly over and over and over again, and after that reintroduce a fader type of lubricant appropriate for switches and controls, and I'm sure that they will respond well because again they're not too bad. So other than that, what I'm doing right now is just obtaining some baseline readings as far as DC offset, or, you know, DC balance and idle current, you know, bias is concerned. I just want to see what I'm up against there, where everything is sitting, and I'm just kind of monitoring things right now. I've had to tweak things, and you know, of course you want to let the receiver warm up for quite some time, and you know, give it a good 20 minutes or so, and let everything kind of settle in. And that's what I've been doing, of course, and monitoring things, and I'm going to get into some details there. This is primarily for the customer. As such, I'm not going to get into you know, too many technical details. I want to explain things in a way that's digestible for the customer. So that being said, let me talk first about what I'm doing here in regard to DC offset, and explain it in a way that again is digestible for the customer. Of course, if you're just somebody that is tuning in that likes to follow along with this stuff, you're cordially invited, and not a problem, even though this is more of a customer update video. But anyway, so let's get to it. As far as DC offset goes, I'm monitoring the voltage, and I'm monitoring millivolts on the speaker terminals, because we don't want excessive DC on the terminals, because that can do damage to your speakers. It can fry your voice coils on your speakers and make them go away. So we want to get things adjusted down to as close to zero as possible. Of course, there's going to be fluctuation. As you can see over here on the yellow meter, and let me just zoom in a little bit here. You can see things bouncing around around zero, and there will often be quite a bit of bouncing, but for the most part, that's normal, and as long as it's in that zone, we're good. A little bit of DC is not going to hurt anything. You just don't want excessive DC that's going to cause damage to your voice coils on your speakers. Now, one thing I do want to mention is that initially, when I first connected the probes to your speaker terminals, there was excessive DC voltage, particularly on one channel, the right channel, and they were both high, but again, I was able to perform some adjustments here. There's some, on the driver board here, there's these VRs, these little variable resistors that are adjustable with a tool, screwdriver, and so not a big deal. That's neither here nor there. I'm not going to get into that. And for those of you that are tuning in, interested in, this stuff, just generally speaking, I'm not going to go into the actual procedure, because in a previous video on another 771 I worked on, I know I outlined the procedure as far as setting the biasing and the idle current and the DC offset. I pointed out the test points and the VRs involved in the adjustments and all that. So anyways, I'm not going to retrace my steps there and do more legwork than need be. So just go back several videos or so, and if you can't find it or whatever and you're interested in that, just let me know and I'll find it and give you the link or post the link or whatever. But otherwise, that's really it. I just want to address that with the customer, that there was some high DC levels on your speaker terminals that I tamed down with those adjustments there, and I'm monitoring things and everything's looking good. Everything's bouncing around where it should be, and there you go. As far as these meters here, okay, this one and this one over here, what I'm doing here is monitoring your idle current or your bias, and for simplicity's sake, your transistors that drive the output section, the driver section, the output section, all these transistors involved in amplifying the signal so that you can hear it out your speakers. In order for these transistors to operate efficiently, operate like they should, function as they should, they need to be biased just right, not too low, not too high. And these transistors, they are current controlled devices, so that's why we want to set the current at idle, the idle current, when there's no signal applied, when there's no load or whatever, with the volume down and so forth and so on. We just want to set that idle current so it's in a state of readiness. We don't want the transistors that are involved in driving the output section and making sound happen, amplified sound happen. We don't want those biased in an off state and in a state of non-readiness, if you will. They need to be just right at that edge so that they can kick in, if you will, at the moment they need to. Okay, and that's a very simple way of putting it, but that's a good thing. So we don't want them too low where they're in a somewhat off state or a complete off state, And we don't want them biased too high either, because you know, the transistors will run hot. They're going to dissipate more heat, more current, so forth. And that was the case here actually. Factory calls for 19 milliamps at idle, plus or minus 1 milliamp. And when I first connected my probes to the test points, we were sitting at just about 40 milliamps on both channels. I think we were like at what, 37 and a half on one and about 36 and a half on the other, close enough. But I noticed the heat dissipation. Things were idling warm, and there you go. So as you can see now, and I have a little bit more tweaking to do, but let me go ahead and just zoom in a little bit here, and you can see on our right channel here we're at you know, 19.3. On our left channel over there, 19.1 milliamps. Okay, so we're in the zone where we need to be. Now I'm going to tweak them down just a little bit and perfect everything just a little bit more. I'm going to do the best I can, considering that these VRs here that are utilized for the adjustments mentioned, these are single turn VRs, and they are very, very, very touchy. I mean, you just breathe on them or sneeze on them or whatever, they will move all over the place. So they seem to be functioning okay, but if I start getting any drift or anything like that, I may end up replacing them with like some 10 turn pots or whatever, VRs, and call it good. I don't know yet. I'll make that decision at the time, and depending on the customer's budget, if you know he wants to go a little further, and if it's really necessary to do so. But the main thing right now is prepping for the recap, which is why, once again, I'm obtaining these baseline readings, because I want to know where I am in that regard and get everything tamed down where it needs to be initially. And then, of course, when I perform the recapping and go through and do whatever else I end up having to do, then, of course, at the very end, I will go through this adjustment again. I'll check everything and make sure everything's still sitting where it needs to be. So that's where I am. Now, one thing I want to say before moving on, after I assured that there was no harmful DC on the speaker terminals, everything was adjusted where it needed to be, I decided to hook up some speakers, because I wanted to, you know, make sure that, you know, everything, you know, sounded okay and all that. So, you know, I of course injected a signal. Now, one thing I want to say about that, I have not gone through all of the inputs yet. Now, that's something that I need to do, and I'm going to do. But right now, I've just been injecting some signals in the auxiliary in, and working on things a little bit here and there. So I'm going to get to the other inputs and make sure everything's okay there. But anyways, what I did notice when I had some speakers hooked up is a few times I heard a little bit of a hiss and pop, which is usually a transistor or transistors becoming leaky. So there's a very good possibility, unless I was picking up some other type of a noise, which I really doubt. Unless that's the case, though, I will probably end up having to suss out some transistor issues. There's probably some transistors in here that may be getting a little leaky by now, and whatever, a small signal transistor or something like that. So we'll see what happens when I cross that bridge. But that's just something that's probably going to be the case, I have a feeling. Other than that, though, I was monitoring the outputs. I hooked the receiver up to the scope and was monitoring the outputs, and everything looked really good as far as symmetry. You know, the signals, the waveforms weren't bouncing around, and I'm going to get into that. We're going to hook it up to the scope, all that stuff, and we'll see after this what this is putting out as far as wattage is concerned, you know, pre-recapping and all that. See how it's doing. So, but anyways, yeah, the signals looked, you know, the waveforms looked good on the scope. There was no erratic or, you know, intermittent behavior. I didn't have, you know, the waveforms getting all jittery or cutting out or anything like that. So at the time they were holding. Whether or not that's going to, you know, remain that way, I really don't know yet. So we'll see. As I dive in and whatever, I will probably do a few more videos on this, mainly for the customer, and go from there. So anyways, let's go ahead and start getting this thing hooked back up to the scope again, and I will kind of outline my setup and we'll go from there. Okay, so here's the setup I have going on. It's very straightforward. You can see I have two oscilloscope probes connecting to the speaker outs right and left, coming from the oscilloscope up here. All right, and unlike the first adjustments that I just covered that require the receiver to be disconnected from any load, and of course the volume's turned all the way down, no load, and what have you. This, because I am going to be, of course, checking our output, our wattage, obviously I have to have a dummy load hooked up to the unit, of course, because I'm going to be bringing up the volume and all that. So that's about it. So we have our scope probes here coming from the scope, and they're connected to the speaker outputs accordingly. And of course I have the tone controls flat, and right now the volume is all the way down, of course. I have my, let me go ahead and show you. I have my 1 kilohertz tone leaving the cable here from the function generator, connecting into the rear of the receiver, of course. Let me show you that. Okay, and here's that cable here coming from the function generator, splitting off into 2 separate signals here. Or, well, it's the same signal, but it's just being split. Not a big deal. And these are the various inputs all throughout here. So I have a right and left signal split from the cable here, entering one of the auxiliary inputs. There's 2 auxiliary inputs on this, but anyways, eventually I'll be going through and again testing all the inputs and all that. So that's what I have going on here right now. Okay, and what you see here is the speaker cables leaving the receiver, and they're connecting to this junction box here for the dummy load. I have an 8 ohm half here and a 4 ohm half here. I haven't mounted the power resistors of 4 ohm on the wall yet. I need to get around to that. I've been messing around with some stuff in here. But the of course the junction box obviously connects to the 1000 watt 8 ohm resistors mounted on the wall there. So that's the setup right now. So let me go ahead and get to the scope, and we'll see what this receiver is putting out. And with all that being said, let's go ahead and pan on over to the scope. Okay, so let me kick up the volume here and get it to that point just pre-clipping. And you can see everything is tracking nice and symmetrically. Okay, so okay, we're clipping there. Let's back her out just a hair. Right there, I think, is pretty good. Yeah. Okay. So there we are, and yeah, you know, this 32 watt per channel receiver in its pre-recap state is putting out 40 watts. Not bad, not bad. So anyways, let me go ahead and back on out. So we only have something to gain by going in here and getting everything back to spec, cleaning everything up, getting some really high quality caps on board this unit, and you know, again, just going through what needs to be gone through, replacing any troublesome transistors, and that's about it, and whatever else I find. So I'm just going to end it here. I just wanted to you know, let the customer know what's going on and what we're up against, how things are looking. So till next time, guys, peace, love, music, and all of the cool vintage audio that brings it to our ears. That's what this is all about. So till next time, take care of yourselves.
This is a poor man's shoe production.